Hi everyone, this video is on applications of solving quadratic equations, section 6.2. It's a second lesson. This first example says this: the hypotenuse of a right triangle is 10 centimeters. The second longest side is 2 centimeters longer than the shortest side. What are the height and base lengths of the triangle, the length of the legs? Well, I would suggest reading this question over 2 more times. Once to draw a diagram, and then once to check to make sure that diagram is correct. So let's do that one more time. The hypotenuse of a right triangle. So let's draw a right triangle here. Here's a right triangle. The hypotenuse, it's the longest side, it's always opposite 90-degree side, 90-degree angle rather, is 10 centimeters. The second longest side is 2 centimeters longer than the shortest side. So if this is the shortest side, let's let x be the length of the shorter side. Or in this case, not only the shorter side, but the shortest side. And then we need to define that, and then the other one just follows from that. It's 2 centimeters longer than that. What are the height and base lengths of the triangle? So what we're trying to find is x, and we're trying to find x plus 2, because this is like the height, and this is like the base. And so we can go ahead and solve that by using a quadratic equation. Let's read this over one more time to make sure we have the diagram proper. The hypotenuse of a right triangle is 10 centimeters. There it is. The second longest side is 2 centimeters longer than the shortest side. What are the height and base lengths of the triangle? The lengths of the legs. Good. So that's correct. So let's go ahead and actually solve this now. Now we know that the Pythagorean Theorem applies. And you remember the Pythagorean Theorem says that a squared plus b squared is equal to c squared. In other words, here we have x squared plus x plus 2 squared equals 10 squared. Now here's the most common mistake I see people make in this unit. One of the most common anyway. I see people do this. They say x plus 2 squared must be x squared plus 4. That is absolutely wrong. Remember that this is a perfect square. Don't forget that. And a perfect square always goes out to be in this form. So if it's a plus b squared, we're going to get a squared plus 2ab plus b squared. Don't forget to expand it like that. So let's do that for this question. I'm going to get x squared plus, I'm going to get x squared plus 2 times x times 2 plus 2 squared. I could put those in brackets because if I had a coefficient in front of the x, I would have to make sure that I'm squaring the coefficient as well. That's equal to 10 squared, which is 100. So I'm going to go ahead and write these out without brackets. So I get x squared plus 4x plus 4 is 100. So now after I subtract 100 from both sides, I'm gathering like terms together. So I'm going to subtract 100 canceling off on the right. It's going to bring it over to the left side, and I'm going to get my x squared and my x squared terms together. So this is going to give me 2x squared plus 4x, and then 4 minus 100 is minus 96. Is equal to 0. I'm having issues with my pen jumping around here. It's equal to 0. Now, some of you might be inclined to try to factor that, and I would remind you that what is the first thing we always do when we try to factor? We try to common factor. Well, I can common factor a 2 out, which actually makes this a simple trinomial. If I common factor the 2 out and I divide this side by 2 and I divide this side by 2, what I get is the 2 is going to cancel out. 0 divided by 2 is still 0. And so you get that. So what we need to do is we need to find two numbers. It's a simple trinomial that add to 2, multiply to negative 48. You can start listing those factors. What you should find is that those factors are 6 and negative 8. Great. 6 and negative 8. It's actually going to be negative 6 and positive 8 because it has to add to positive 2. So make sure you add them up properly to positive 2. So because it's a simple trinomial, we can go ahead and write this as x minus 6, x plus 8 equals 0. Well, that means the first factor is equal to 0. X minus 6 is equal to 0. Or x plus 8 is equal to 0. If we rearrange each of those by adding 6 to both sides here, this gives me x is positive 6. By subtracting 8 from both sides here, this gives me x equals negative 8. And what that means is that there's no way this is even possible because that would give me a negative length. over here, x is 6. Well, that tells me the length of the shortest side. If I go back up to the question here, you can see that this now we know is equal to 6. And then that means that the other side, x plus 2, is going to be equal to 8. And so we would conclude there to say, therefore, the shortest side is 6 centimeters. And the second shortest side, or the height in this case, if we draw the triangle flipped around, we could have said that the base is 6 centimeters, or 8 centimeters, and the height is 6 centimeters. It doesn't really matter here. The point is the shortest side is 6 centimeters, and the second shortest side is 8 centimeters. And so hopefully you noticed here, the reason we put the word or is because we can't have x minus 6 being 0 at the same time x plus 8 is equal to 0. X is 6 is going to make this factor here 0. X equals negative 8 is going to make that factor there 0. So it's going to be one or the other at different times. And so that's what we get. We get a length of 6 and 8. And if you'll notice, going back up to this triangle, 6, 8, and 10 is one of our special triangles that we might have recalled seeing before. It's a 3, 4, 5 triangle. It's a ratio of that 3 to 4 to 5 side length. All right. Well, hopefully that makes sense. Now I want to give you a little bit of perspective about why we're actually doing what we're doing. The next unit we're going to look at all has to do with graphing these things. And we haven't had to do that yet because we're really trying to get comfortable with the algebra. But this is hopefully something that you can start making a few connections about. You don't need to be aware of how to graph anything yet, but I just want you to connect a couple of things here. First off, if we have something in this standard form with no brackets, we can see that this c value that we get when we expand everything out, no brackets, if it's representing a parabola, it's actually going to give us the initial height, or the y-intercept. And that's this value right here on the graph. I'm just putting in the big blue dot. And so if we have it in that standard form, we get the y-intercept. And then we can factor that, and that's what we've been practicing a lot this unit. If we go over here to the factored form, what we'll notice is that when we factor it, we get it in the terms of x minus r, x minus s, and those are what we call the zeros, or the x-intercepts. On the graph, they represent these 2 points. And then if we get it into vertex form, which we're going to learn at the beginning of our next unit, that allows us to find the actual vertex. And so if we can go between all these forms, we can get all these key points in a parabola, and then we can, based on the zeros, we can say, well, there's my what we call an axis of symmetry, because parabolas are the same on the one side as they are on the other side. So if we have one point, we can flip across that axis of symmetry to the other points on the other side, and we can develop those 5 points on a parabola. And that allows us to graph things and be able to know a lot of interesting facts about the parabolas. Let's look at a second example specific to solving quadratic equations. Here we have a rectangle has dimensions as shown. Determine the dimensions if the area is 40 centimeters. Well, we know that in one case we've got a length, in another case we've got a width, and we know that the area of any rectangle is length times width. So if we go ahead and we expand this, or sub these in and then expand it, we get 2x plus 1 times x minus 5. Well, that is equal to 40 because we're told the area is 40. Well, if we go ahead and we expand this out, some of you might want to solve this, but remember, this is equal to 40 right now. We can only solve it when it's equal to 0. Expand it. You might want to put this in your notes to get equal to 0. Then factor and solve. And create a whole bunch of wild lines along the process. All right, there we go. 40 equals, and if we FOIL this out, 2x times x is going to give me 2x squared. That's the first. Outside is 2x times negative 5, which is negative 10x. Inside, 1 times x is plus 1x, or just plus x. And then last is 1 times negative 5, which gives me negative 5. Now, just like I did before, I'm going to collect the like terms. So I'm going to subtract 40 from both sides to get the equal to 0 on the left side, so 0 equals. And then I'm going to collect this term and this term because they're like terms. So 2x squared minus 9x minus 45. And now, unfortunately here this is not common factorable. So we have to use decomposition here. So we can see that two numbers need to add to negative 9, multiply not to negative 45, but to 2 times negative 45. So you need to multiply to negative 90. Now those two numbers, if you'll notice, takes a little bit of work to find those, but we could start listing some factors of negative 90. We could list 1 and negative 90. Notice the bigger factor needs to be negative because they have to add to negative 9. We could list 2 and negative 45. We could list 3 and negative 30. We could list 5 and negative 18. Or we could list 6 and negative 15. And there they are. 6 and negative 15 add to negative 9. So we go ahead and we separate this. 2x squared. We decompose it. So we're going to go plus 6x minus 15x minus 45. It's set equal to 0, so we can solve this now. And so if I common factor out of the first two terms, we factor by grouping. So I get 2x is going to give me x plus 3. If I common factor the next two terms, I can common factor a negative 15 out. And that's going to switch the sign of the second number there. So it's going to become x plus 3 as well. And so that gives me 0 equals x plus 3 times 2x minus 15. Well, that means that x plus 3 equals 0, or 2x minus 15 equals 0. X equals negative 3. 2x equals 15. Divide by both sides by 2. We get x equals 7.5. Well, it can't be negative 3 because we can't have negative lengths. And we know one of the dimensions was x minus 5, so that would definitely give us a negative length. So it must be x equals 7.5. So now we go and we say, well, what are the dimensions? Well, let's just draw that triangle one more time here. Rectangle, rather. That's definitely not a triangle. That's a rectangle. And what we have is we have dimensions of 2x plus 1 and x minus 5. And so if we actually want to calculate what these dimensions are, which we are asked to do, we know that the length is equal to 2x plus 1, which means that if I substitute in the x, I get 2 times 7.5, which is 15, plus 1 is 16. And the width is going to be exactly equal to x minus 5, which is 7.5 minus 5, or 2.5. And so if you go ahead and you calculate the area, we know the area is equal to length times width. My pen likes to jump around here. And it's going to be, in this case, 16 times 2.5. Well, 16 times 2.5 is 40, which is what we calculated, which is what the area we were given was. So there we go. We've actually been able to check to make sure that works. And so that gives me an area of 40 centimeters squared. And so we can conclude, therefore, the length is 16 centimeters and the width is 2.5 centimeters. If you have any questions, feel free to reach out and ask for help. Happy to help.